Hi, welcome to the second video in the series for projectile motion, captioned Resolving the Initial Velocity of a Projectile Motion. In video one, in the first video, we've defined a projectile motion as the motion of a body with an initial velocity under the influence of gravity at a certain angle to the horizontal. And we also agreed that in a projectile motion, the motion actually occurs in two frames. It has a vertical component because the body has to attain some vertical height before it begins to curve. Now, of course, for that to happen, it means that the initial velocity with which the body was projected must also be divided into a vertical component and a horizontal component. So in this video, we are going to be looking at how we can resolve the initial velocity of a body undergoing projectile motion into its vertical component and its horizontal component. All right. Now, from our diagram, the vertical component, we shall use our frame of reference, the y-axis. The y-axis, so anything vertical, we shall refer to it as y. And then the horizontal component, we shall use the x frame of reference. That's the x-axis, so this is our x-axis. So the vertical component, the horizontal component of the initial velocity will carry ux, and then the vertical component will carry vy. All right. Now, if we just bring out this, if we just bring out the initial velocity, you will agree with me that we'll have something like this. This is my initial velocity, which is u, and then the vertical component will be something like this. This is my vertical component, and since it is vertical, we've agreed it's going to be uy, and then the horizontal component will be ux, and I could just use geometry to just complete this. Okay, so I could just complete this. Yes, just make it. Yes, just complete this. Just clean this. Okay. All right, beautiful. Now I have more of a rectangle. Now the opposite sides of a rectangle are equal. So this side will be uy, and then this side will be ux, and then this side will be theta, which is the angle between the point of projection and the horizontal. Okay. Now, but what do we have here? If you look, we have a right angle triangle. Let me just letter it so that you see beautifully. A, B, C. This is a right angle triangle. And from our knowledge of mathematics, we know that in a right angle triangle, we could approach it using the trigonometric concept that is popularly summarized as SOHCAHTOA, where SO means sine, which is opposite over hypotenuse. The cos refers to the adjacent over the hypotenuse. The tan refers to the opposite over the adjacent. So let us go ahead and apply the concept here. All right. From triangle ABC, sine theta is equals to opposite over hypotenuse by definition. And from here, the opposite side to angle theta is uy, and our hypotenuse, which is the side opposite the 90 degrees, is u. This implies that uy is equals to u sine theta. So if I'm dealing with the vertical component of a projectile motion, the initial velocity in that direction will be uy, which is u sine theta. Now, in a similar manner, I can say cos theta, that's from the same triangle. Cos theta is going to be the adjacent side by definition, adjacent over hypotenuse. The adjacent side is okay, let's put it, that's adjacent over hypotenuse. This is equals to u x over u. So this implies that ux is equal to u cos theta. Beautiful. So whenever I have to deal with the horizontal component of a projectile motion, I use ux is equal to u cos theta. So what we've achieved in this video is that we've succeeded in resolving the initial velocity with which a body is projected into a vertical component and a horizontal component. Why did we have to do this? Because a projectile motion is a motion that is in two frames. Now, the beauty of this resolution we've done will be seen in our third video, where we'll be using it to derive some formulas. So I don't want you to miss our third videos. Okay, this is where we're going to stop. Thank you very much for tuning in. And if you've liked and benefited from it as you are watching, please subscribe, share, tell as many people as you can. And also, don't forget, if you have questions, if you have suggestions for us, please use the comment section. I assure you that we're going to attend to it. Thank you. See you in the third video.